All right, so let's go to the next problem, which is, let's see, what number is that? I think that's problem number 1. This one right here, where you have this function. It's asking you to find du given that u is equal to the natural log of x, and you've already done that and you got it right. If you find the derivative of the natural log of x, it's 1 over x. It's 1 over x, so that is right. But this one you've left blank, so I'm assuming this is the one that you had difficulty with. It says, indicate how the limits of integration should be adjusted in order to perform the integration with respect to u. Enter your answer using interval notation. Okay, here's how you do that. When you're using u substitution, you can actually change these numbers right here. And here's how you do it. They're saying that u is equal to the natural log of x. Now, these limits of integration, this 1 and this 4, only apply when that exponent is right here, x. But we've changed it. So now it's actually going to be a u. So what we need to do is we need to plug these two numbers into our u, natural log of x, and figure out what that u value is going to be. So let me show you that. I'm going to take this. Let's start the 1 first. I'm going to take this 1. That's going to be the x value. So I plug it in right here. So u equals the natural log of 1. And the natural log of 1 is 0. You put that in your calculator. But the natural log of 1 is 0. So u equals 0. So again, when the x is 1, the u is 0. So that's going to be your new limit of integration. That bottom number is now going to be a 0. And then I'm going to do the same thing with the 4. This 4 right here, I'm going to plug it into that and figure out what the u is. So I'm going to take this 4, I'm going to plug it into that x. So u equals the natural log of 4. Now that one I've got to plug into the calculator, and I'll figure out what it's equal to. Go ahead and plug it into your calculator. It's going to be the natural log of 4. And the natural log of 4 is 1.38629.4. Did it say where to round it? It doesn't say, does it? Enter your answer using interval notation. Well, that's interesting. So it really doesn't say where to round it. It's just going to be based on what the instructor has told you. But that is your upper limit of integration. Because when x is 4, the u is 1.386. So here are your new limits of integration in interval notation. It's going to be, it won't be a 1 anymore. Now it's a 0. It won't be a 4 anymore. Now it's a 1.386. Again, I cut it off at 3 decimals. I'm not quite sure where they want you to cut that off at. They might accept 3 decimals. The instructor might have told you where to round that at, but that will be a decimal. It just depends on where they told you to cut that off at. And this one you got right, so I'm assuming you had no issues with that. Let's go down to this one. This one right here. This is number 16. It says find the average value of the function on this interval right here. So I'm going to find the average value of this function on that interval they just gave me. And this one you almost got right. The answer is actually not a negative 1/5, it's a positive 1/5. So this was almost right. You just You just missed the sign. It's actually a positive 1/5. But I'm going to show you how to get it. Whenever you have a problem with saying find the average value of the function, you're going to be using this formula right here. 1 divided by b minus a, and I'll tell you what all these variables are in a second. Then it's going to be the integral from a to b of your function dx. Let me tell you what all this stuff is. 1 over b minus a, that's just, this is your b, this is your a. It's basically how long is your interval. So it's going to be 4 minus 0. So this right here is 1 over 4 minus 0. And 4 minus 0, of course, is 4. So 1 over 4, 1 over b minus a, is 1 over 4. Because this is your b, this is your a. It's how long the interval is. And then you're going to be taking the integral. Again, the b is 4, a is 0. That comes from your interval. This is the lower limit, this is the upper limit. Lower limit, upper limit. Of your function, so you're going to be taking the integral from 0 to 4 of your function, which is this thing right here. So 1 over x minus 5 squared with respect to x. So you're going to be taking the integral of this function with respect to x, and you're going to be multiplying it by 1 over 4. That's how you do the average value. It's always going to be 1 over how long your interval is, and then you're going to take the integral of this function from a to b over that interval. You're going to take the integral of that function over that interval right there. Oh man, I don't have much room here. Let me move over to the side. So I'm taking the integral of, we can ignore the 1/4 for a second. I'm taking the integral of this function. I'm going to take the integral of that function. And to do that, I'm going to do u substitution. I'm going to say that the u is equal to this inside function right here. U is equal to x minus 5. Therefore, du is going to be equal to, what's the derivative of this? The derivative of this function is 1. So it's going to be 1, and then you always have that dx there. Well, 1 times dx is just dx. So du equals dx. And now I'm going to rewrite this. Again, I'm kind of ignoring this to the end. I'm just dealing with this part right here. I'm going to rewrite this integral in terms of u and du. So it's going to be integral from 0 to 4. And now it's going to be 1 divided by, not x minus 5 squared, because x minus 5 is the u. So this right here is actually the u. So it's going to be 1 divided by u squared times, not dx, but dx is equal to du, so du. Okay? Now this function right here, I know how to take the integral of that. I know I can use the power property. I'm going to bring this to the top, and when I bring it to the top, the exponents will become negative. So this is actually going to be the integral from 0 to 4 of u to the negative 2 du. Again, I just brought this to the top, and when I did that, the exponent became negative. Now I'm going to use the power property. And if you remember the power property when you're doing integration, you're adding a 1 to your exponent, and then you're going to divide by whatever that new exponent is. Well, negative 2 plus 1 is negative 1. So this is actually going to be u to the negative 1 divided by that new exponent, which is negative 1. That is the integral of u to negative 2. Okay? And I need to evaluate it at 4 and 0. And I'm sure you've seen this by now. Whenever you take the integral, this is the integral. You no longer use this integral sign because you've taken the integral. Now what you do is this bar. and it tells me to evaluate it from 4 to 0. Evaluate the integral from 4 to 0. Okay? And to do that, I have two options here. I could change my limits of integration. As you saw in the last problem, I can change my limits of integration. Or if I didn't want to do that, I could just put this u right here, I could put the x minus 5 back into it. And that's what I'm going to do. I'm actually going to put the x minus 5 back into the u. So this is actually equal to, and I'm going to go up here so I have some room. I'm going to replace the u with what it's equal to, x minus 5 to the negative 1 divided by negative 1. And I'm evaluating that integral from 4 to 0. Okay? So let's not lose exactly what we've done here. This was after u substitution. I used the power property to find the integral, which is this right here. And I'm evaluating it from 4 to 0. I could have changed my limits of integration, as you saw in the last problem, but I decided not to. So all I'm doing is I'm taking the x minus 5, and I'm plugging it back into the u, and that's what I got right here. And now I can use my original limits of integration. So long as I replace the u with what it's equal to, I don't have to change my limits of integration. So I have this right here. And I'm going to go ahead and evaluate that from 4 to 0. First, I'm going to simplify this a little bit. And let me think about the best way to do that. Let me see. Okay. So let's go ahead and I mean, I guess I could do it like that. I don't want to get it too confusing, but you see how dividing by negative 1? That actually means there's a negative out front. I can put that negative out front. So this is actually going to be a negative x minus 5 to the negative 1. And I can also, you see how I have a negative 1 here? I can bring that to the bottom. I can bring this whole thing to the bottom and change that exponent to a positive. So it's 1, it's going to be a negative out front, 1 over x minus 5 to the first power. So I'm just simplifying it a little bit. I'm just rewriting this as this. I put the negative out front, and then I brought this thing right here to the bottom. And in so doing, that became a positive, and I'm still evaluating it from 4 to 0. And when you evaluate an integral, remember how to do that? First thing you do is you plug in the upper limit of integration. So I'm going to put a 4 right here. And if I do that, 4 minus 5 is negative 1. So it's a negative of a 1 divided by negative 1. Well, 1 divided by negative 1 is just negative 1 times the negative is a positive 1. So again, you take your upper limit of integration and you put it into this thing. And then you see what that comes out to. And what it comes out to is a 1. So it's going to be 1 minus, and then what you do is you plug in your lower limit of integration. So you put a 0 right here. And 0 minus 5 is negative 5. So it's going to be 1 divided by negative 5 times a negative 1. Negative times a negative is a positive, so it's going to be a 1/5. 1 minus 1/5. And 1 minus 1/5 is going to be, and to do that, you got to change a 1 into a 5 over 5 minus 1 over 5 is going to be equal to 4 over 5. So 1 minus 1/5 is 4/5. Okay? But keep in mind, what I just did was the integral. And I evaluated it from 4 to 0, and I just figured out it's 4/5. But remember, there's actually a 1/4 out front. So out in front of everything, don't forget about that 1/4. It's still out there. So it's going to be 1/4 times 4/5. The 4's cancel out, and it's going to be 1/5. And that's a positive. So this final answer is actually a positive 1/5. And that's how you do that. Key thing to remember, when it says average value of the function, you have to use that formula, and then you do your integration. You evaluate it at the limits, and that'll be your final answer. That's how you do that. So I'm going to go ahead and stop this video, and I will make more videos later on.